Hello and welcome to this video. This is part 2 of our manual failover scenarios. In the first part, I discussed how I'm manually but quite fast changing my ISP. This was based on static routes and the different administrative distances. And I'm doing this for all the devices which are connected to a single wireless network or a single SSID. In this video, we're going to build on top of it, and I'm going to discuss the second scenario, which is selecting my ISP or choosing which ISP I want to use based on the SSID to which I'm connecting. So basically, I'm going to map different SSIDs to the different internet service providers, and this is done based on policy-based routing. So what, as a summary, what we did in the previous video, again, we presented this topology, and we had one SSID, this client network 10.0.1, and this is the main routing table, the only one at this moment routing table of the MikroTik device with different gateways. They have different weight, let's say, or which is called administrative distance. The lower the number, the more preferable the route. And I'm changing the ISP for all the devices simultaneously. Now we did all of these steps, and of course I did this one as well with the script, and it went quite well. But now we are building something on top. This picture is presenting our topology, and it looks familiar with one difference. Here I see two more different SSIDs. So one is called ISP2 and another one is called ISP3. And these two additional SSIDs are mapped to different IP subnets. So 10.0.2, 10.0.3, the first one is 10.0.1. Again, all masks are /24. What's the idea? So again, I can easily change the ISP for all the devices which are connected to the home net SSID. But in order to do this, first of all, I have to run the script from, or I have to be able to connect to the MikroTik device from somewhere. I have to be able to know I have to know the password in order to log in and modify the routing table, because I want manual, and I want manual because I want more control. But what if I'm not there and there is someone else, or what if I don't want to log in? I'm not with my laptop, etc. I want to map these different SSIDs to the different providers, and then based on the different clients, depending on if you are connected here, you just connect to this SSID, and then you should exit out of ISP2. If you connect to ISP3 SSID, you should exit out of ISP3. How this is done, how this can be accomplished. This can be accomplished via, I know, two different ways. One is policy-based routing, what we are discussing today, and the other one is called VRF, virtual routing and forwarding. I'm not discussing VRF today, but both of these methods, they rely on a single trick. And this trick is actually creating another instance of the routing table, or another instances of the routing table in the router. Because if you only have a single routing table, and we had this in the first scenario, we know how it works. You either have different priorities or distances here, and only one gateway will be used for all the devices. Or if you have 111 as a distance, it will load balance, but not based on the SSID. It will load balance based on its own logic, which is typically per session. And you can have different sessions from one client, so you don't control it. So I now I'm going to use this concept of creating another routing table. And this routing table has a name. And I am going to call this routing table ISP2. So you see, this is the ISP, so the routing table main, and this is the routing table ISP2. In this routing table, I will put just one route, and this is a default gateway pointing to 02, which is going to ISP2. I don't care about the distance since this routing table is alone and this distance is not going to compare with the distances here. So they are separate routing tables on the same device. And now the next question which comes here is, okay, how should I associate the traffic coming from this SSID to use this routing table? If I just leave the things like they are at the moment, um, all the traffic from the three different SSIDs is going to exit here because all the traffic is going to use only this routing table. There should be a criteria, something like an if, saying uh, that something has to happen in order for this routing table to be used. And this something is actually you have to mark your traffic. You have to put like a label to your traffic, and this label should be ISP2. And this is quite easily done with the so-called Mango rules. They are in the IP firewall sections of the MikroTik. And this is the if actually. I will say if the traffic comes from 10.02 and 10.02 is a subnet associated with ISP2, then mark it with this label. And when it is marked with this label, then it's going to use only this routing table. It will not use this routing table at all. And that's the whole logic. And as you can maybe imagine, I'll create a third routing table, ISP3, and then I'll create another Mango rule saying that if the traffic is coming from 10.03 and this is 10.03, then put a mark ISP3 and it will use this routing table. And this routing table has another gateway, and this gateway is 01, which is my ISP3. And again, very important, this scenario can work again together with the first one. So even if I disable, for example, this gateway, I disable this gateway. This means that all the clients which are connected to the HomeNet SSID, they will exit out of 01, which is ISP3. But if I take a client and manually connect it, for example, to ISP2, it will use this routing table and will exit out of ISP2. It doesn't matter that ISP2 route is disabled in the main routing table. It is active in the other routing table. So these routing tables are working independently. So let's create the configuration. Um, this configuration builds on top of the previous one. And the first point here is actually just checking that port Ether2 is configured as a separate port, internet port, which means it has to be out of the default bridge. It has to have the IP address, which is 010, and it has to be configured with NAT. So going here, going to, so let's go here first to bridge. I don't see port 2 here, so 1 and 2 are not here. That's a good sign. This is what we did in the first video. And then for Ether2, I have 010. Maybe you remember I made a typo in the first video. I made it like 192.158, and I was wondering why my route is not working, but then I fixed it. And then the other thing is in IP firewall, NAT, this masquerade, this is actually doing NAT 2. So from any source going out of ether 2 is doing NAT. So we can say that this is done. Now we have to create ISP2 configuration. So we have to create the SSID, and I would like to use the very popular concept in MikroTik for creating a bridge and start working only with this bridge. So the bridge concept is like when you create a bridge, is like you create a logical object and then you associate different interfaces into this bridge. So I'm going to create a bridge and I'm going to call it like bridge ISP2, and then I will put my SSID ISP2 inside this bridge and work only with this bridge. Why? Uh, it's more scalable because later on um, I can put another port in it, and for me it's easier to work with this in this way. So create ISP2 associated with a bridge, set up an IP address 10.0.2.1 and associated with a DHCP server. So let's explain what we are doing. For the clients, let's talk about the default network here, HomeNet. So the clients will receive IP addresses from the built-in DHCP server for the bridge, which is called bridge, and they will receive 10.0.1 something with the default gateway, which is 10.0.1.1. I would like to create a subnet here 10.0.2 and a DHCP associated with it, and the client should receive an IP address 10.0.2 something with a default gateway 10.0.2.1, and respectively here the default gateway should be 10.0.3.1. All these three addresses are different gateways, but they're pointing to the same device. They're pointing to the same MikroTik device. And if I don't create these additional configurations, the fact that these two clients, they have different gateways, is not doing anything, because these two gateways are terminating in the same MikroTik, and this MikroTik is just using this routing table, and it will every time exit out of um, it will go to ISP1. So this is very important to be understand that we have default gateways for the clients, but then we have to work with the routing table with the routing tables on the MikroTik and specifying different default gateways in the different routing tables, and then do some policy-based routing. So let's go back here and start doing our configuration. Um, in the wireless section, in the wireless interfaces, I have my 2.4 antenna disabled. I'm not going to need it. And then I'll create it a sub interface, which will be virtual. So new virtual, and I'll call it, so the master interface will be wireless LAN 2, which is the 5 gigahertz. The SSID will be ISP2, and the security profile will be, I have created a profile which just contains a password. So I call it backup internets, just to have a separate password from the passwords from the main profile. How should I call this? I will call it ISP2. So this is just the name of the, like the descriptive name here of the interface, and here is the actual SSID. It's living inside WLAN2, which is 5 gigahertz. I'll create one more and call it ISP3. Then in the wireless section, I say, okay, it's bridge. The SSID will be ISP3. It will live inside So the master interface is the 5 GHz network, and the security profile will be this one. So let's double check, is everything, yes, everything looks good. And now I'm going to associate this. I'm not going to work directly with ISP2 and ISP3. I'm going to create bridges. So I'll just create two bridges. So first will be bridge ISP2, and the second will be bridge ISP3. Okay, and then I map my SSIDs with my bridges and then start working only with the bridges. That's the idea. So going to ports, you see port Ether 3, 4, 5 and the wireless are associated with the bridge code bridge. This is the default. I didn't touch it. Now I'm going to do two more associations and say my Wi-Fi network, which is called ISP2, is going to be associated with the bridge ISP2. That's it. One more. My Wi-Fi network, which is called ISP3, is going to be associated with the bridge, which is called, I just realized that this is called bridge 1 ISP3, and then I'm going to fix it. Just remove the 1, and it should be updated here as well. So far so good. I have the wireless networks or the SSIDs associated with the bridge set up with and I'm doing this together. So 2 and 3 I'm doing in parallel together. Then let's set up an IP addresses for these bridges 10.0.2.1 and 10.0.3.1 for the respective bridges. So I go here, IP addresses, and say another IP address 10.0.2.1/24, and this is to be associated with bridge ISP2. It automatically detects the network based on the subnet mask. So another one, which is 10.0.3.1/24 associated with bridge ISP3, and that's the other IP address that I need. So what I have until now, I have my SSIDs associated with the bridges and assigned with an IP addresses. Now, what will happen now is that when you associate this SSID or to this SSID, you are not going to receive an IP address because there is no DHCP server which is going to serve you. And this is what we are going to do now for point 2 and 3 simultaneously. So I need to create a DHCP servers, two of them, running on bridge ISP2 and on bridge ISP3. Before this, I need to be prepared with my pools. So I go to IP pool, and I see here the main pool, which I'm using 10.0.1. As you know here, I have my IP address 10.0.1/100, and then I create another pool, which I'll call it like pool ISP2, and the addresses that I'm going to use here from 10.0.2.20 up to 10.0.2.200. It's similar to the main one, just my subnet is different. Then I'm going to use another one, pool for ISP3, and it will be from 10.0.3.20 up to 10.0.3.200. Then I go to the IP DHCP server, and let's create the two more additional DHCP servers, each of them running on the respective bridge interface. So let's call this DHCP for ISP2, and very important, this should be running on this interface, the logical bridge interface. And then what is the address pool? I just created it. It's going to use the pool ISP2. that's it. Another one. So let's call it DHCP ISP3. It's going to work on this interface here, and it's going to take from addresses from this pool. Looks good so far. And finally, I need to do the networks because I need to do the correct, I need to assign the correct gateways and the correct DNS servers for this for the clients connected to these SSIDs. So for the network 10.0.20, this is ISP2 slash 24. I'm going to give the gateway 10.0.2.1, and the DNS server will be, let's say, 8888. For the network, which is 10.0.30 slash 24, I'm going to give the gateway 10.0.31, and the DNS server will be 8888. So you see here, I have another DNS server for my main subnet, and this is the DNS server of the MikroTik itself. But it doesn't matter because the MikroTik will forward to maybe to my ISP, and most probably my ISP will anyway forward to Google. So it doesn't really matter. But again, I would like to pay attention here on the gateway for the different subnets. They are all pointing to these interfaces here. So this is .1, 10.0.1.1, 10.0.2.1, 10.0.3.1. They have different gateways, but all of them are terminated on the same device, on the same MikroTik device. And if I connect to each of these SSIDs now, and I'm going to test it now, I should be able to receive different IP address with different gateway, but still exiting out to ISP1 every time, because at this moment I'm just using the main routing table. In the main routing table, we have only one gateway active at this moment. So let's um, see. So I think we are done now with this point here and with this point here as well, because we have the IP addresses, the bridges, the SSIDs, and the DHCP servers. So let's see if I bring the so for currently I'm connected to the main SSID home net, and then if I bring the my Wi-Fi connections, show available networks. Let's see what do I have now. I have ISP2 and ISP3, and if I try to connect to ISP2, it said give me the password, and the password in my security profile was 1234567 8. Not very secure password, but um, just for the example. Of course, this one is disconnected because it's belongs to another network, and ISP2 is connected. So let's see, ipconfig 10.0.2 and with the default gateway 10.0.2.1. Now, if I do the trace route, you see I'm exiting out of 1.1, which, to remind you, is again my ISP1. And then if I connect to ISP3, just to test it again, 1, 2, 3, 4, 5, 6, 7, 8. Now what I expect is, if everything works, of course, I would like to see my IP address ending on 10, starting with 10.0.3 with the default gateway 10.0.3.1, which is again MikroTik. And then I have internet. I have internet and I'm still exiting out to ISP1. So this part is done. Let me switch back to my primary SSID in order to be able to connect to the MikroTik. I can make it possible to connect from the other networks as well. but actually I don't prefer it for security reasons. So that's good for me. Let's continue here. What we have done so far, we have done the how should I say, the dirty part, the dirty work, and now it's easier and much more interesting. So we have the different SSIDs, the different networks, and now let's go and create additional routing tables. Create another routing table ISP2 and put another gateway in it. So where are my routing tables? So if I go to routing tables, I just see the main routing table here. And um, I'm going to create another one, and this another one will be called ISP2. Before I click OK, I see there's a checkbox here, FIP, which is forwarding information base, and that's pretty much, if I click on this checkbox, it will use the FIP of the router, which actually makes the requests to the routing table, or it will make the routing a little bit faster, because it's think of it as kind of a cache in the routing table. So you may have different routes coming from different routing protocols, but at the end the router will have to calculate for this particular packet which interface should be used to send the packet out. And this final result is in the FIP. And I would like this to be, I'll call it cached in the FIP. It's faster, but it will work in either way. So ISP2 routing table created. I'll create the other one, ISP3 now as well, and that's it. Now what we have here, and put the gateway for ISP2 inside the second routing table. So 02, again, let me remind you, 02 is this one. So going into the IP routes, see what do I have here now. I have my main routing table, I have ISP2 routing table, I have ISP3 routing table, and they are empty. So I can go to ISP2 and say put another route, and you see what I have here already populated for me, routing table ISP2. I can do it from anywhere. I can do it from O, for example, and I can say another gateway, but don't put it in the main routing table, put it in the ISP routing table. So destination is internet, gateway is 192.168.02. Apply. Error in gateway, address expected. So 192.168, again, typo. Let's do it like this and switch to the ISP only routing table. And you see here that in this isolated routing table, I have a single gateway, and it's green, and it's active, and it's static. So this point here is done. And now I'll create the other one. For ISP3, which is already created, put another gateway of ISP3, which is 01. So I'm going, this time I will do it directly from the routing table 192.168.0.1. It is for routing table ISP3. And that's it. Now if I go to O, you will see something interesting. So I have different gateways. One gateway, which is this one here. Another, oh, you see here, this is from our previous video. So, but they have different routes, and they are disabled because of my script, right? But you see, I have another default gateway and another default gateway, and the three of them are with a distance 1. and they are not doing equal cost multipath. They are both active in the same time because they are distributed between different routing tables, and they are independent from each other. So this is done. But at this moment, this is not enough. So I have my routing tables, but no traffic is going to be matched for these routing tables. No traffic is going to look into this routing table. I need to mark my traffic, and I need to mark it with this so-called Mango rules. So if traffic comes from this subnet, mark it with ISP2. So I go to IP firewall, Mango, and say another rule general. It should be in the pre-routing chain, the default one which is selected here. And my if criteria is when it's coming from 10.0.20/24. That's it. The action is the action should be mark routing and mark it with ISP2. And that's it. Now this checkbox here pass through, not very important. This means that if you have another rule matching the same criteria, should the router continue to look at the other rules matching the same criteria or not? Since I will have two rules, but they will be matching different criteria, it doesn't really matter if I leave this enabled or not. So let's create this rule, and let's create the other one. So pre-routing, if it's coming from 10.0.30/24, that's it. That's the only requirement. The action should be mark routing, mark it with ISP3. And that's it for 6 and 7. And then I have only one left, disable fast track firewall rule. Now, when you go to firewall, the first tab here, filter rules, there is one default rule in MikroTik which is called fast track. And it's something which is implemented by default with the idea of performance. So it's kind of bypassing the firewall when the packets exit, again for the purpose of higher speeds, better performance, but it's not working together with our policy-based routing. So I'll have awful performance if I don't disable it. So I need to either delete it or just disable this. And this is the last step here. What is left now is just we need to test it. So let's close all these windows here. Let's go here again, do ipconfig. I'm connected 10.0.1 and then trace route. I'm exiting via ISP1. So let's bring the wireless connections again and let's connect to ISP2. So it can be any device just want to use ISP2 regardless if ISP1 is working or not. Just click connect here. This one gets disconnected, of course, and then ipconfig 10.0.1 sorry 10.0.2. I got the correct IP address. I am now connected to the second network. Do I actually exit out of the second ISP? Yes, I do, because it exits via 0.2. And let me show it on the picture again. 0.2 is this one. And of course, we did it on the previous video. I can open ping EU or what is my IP address, and you see the IP address associated with ISP2. And finally, let's check ISP3, another device connecting to or the same device connected to the different wireless network. So wait a little bit for the connection. ipconfig. I have 10.0.3 something, 10.0.3.1, and then I do the trace route, which is exiting via 0.1, and again 0.1 is ISP3. So that finishes our two scenarios. And I would like to mention one more time that they can work together. They can work simultaneously. And the first one is actually we are modifying this routing table, and this is independent from the other routing tables. So I hope it was interesting, and you can use maybe not all of the things here, but at least part of them for your particular needs. Um, Thank you for the attention, and until next time, see you. Bye bye.